So good afternoon, everybody. This is Brian Cox, and very pleased to talk about the preparation of safety case reports for high-risk buildings this afternoon. Just a brief disclaimer, this is my own presentation of my own and doesn't necessarily represent CABE or IMIC or any other organisation. The other thing I wanted to say is that the whole building safety regime is developing very quickly, and of course in a couple of months' time there may be things which make the situation change. So I think people know there's a new environment for building safety coming. The Building Safety Bill introduces two new roles: the accountable person and the building safety manager. And the bill also introduces the safety case process for the first time, although lots of other industries like nuclear and chemical industry and so on have been using safety cases for a long time. The accountable person will be responsible for submitting a safety case report. Well, they have to do some other things as well, but that's a key item in allowing them to get a permit to have a building occupied by residents. So just a bit about the scope of residential buildings and the timeline. So normally we can say that a new building might take 2 to 3 years to build. It might be a change of use building now. And then after maybe 10 years, and then perhaps every 10 years or so, there might be a major refurbishment. And at the beginning of a new building, we now have the 3 gateways. Gateway 1, which is planning, which has just come into action. Gateway 2, which is construction. And Gateway 3 is occupation, which is more or less the same as RIBA stage 6. And during the Gateway 1 and 2, we have mandatory roles of the client, the principal designer and the principal contractor. And then for occupation, we now have the accountable person and the building safety manager. Probably when we have a major refurb, we will again have principal designer and principal contractor. And safety cases really start with Gateway 3, when we have occupation. So there's 2 kinds of activity going on during this timeline. One is construction per se, mixing concrete and laying bricks and generally getting together the building. And then there's the management of construction, making it all happen, and operations management, which is really we're talking about operation management of residential buildings after occupation, and that's where the safety case process comes in. So this new regime really came from Dame Judith Hackitt's recommendations, Building a Safer Future, which she did in May 2018, following the terrible disaster at Grenfell Tower. And the draft Building Safety Bill is now going through Parliament and pretty much reflects the recommendations made in Dame Judith Hackitt's report. And in particular, there will be a regulator, the Building Safety Regulator, which is under the auspices of the Health and Safety Executive, and that's really already starting to put things together. The accountable person and the building safety manager, who we've just mentioned before, and residents now recognised as a stakeholder in this whole process through the residents' voice. So the accountable person has to submit and have approved the safety case report. So this is the timeline which the government has issued. I'll try and zoom in on this because it's a bit difficult to read. So the bit we're interested in is the new duties for the accountable person, which is where safety cases come in. So that's RA plus 18, which means Royal Assent plus 18 months. So we expect that that will be the Royal Assent in maybe spring 2022, and then we're probably talking about early 2023 before these safety cases actually have to start being submitted. However, a lot of people will have quite a bit of work to do both to get their people sorted out, the accountable person and the building safety manager, and to start getting their head around what they have to do for a safety case. The number of buildings in scope is reckoned to be around 12,500, of which something over half are private sector buildings, private residential buildings and student accommodation, and the remainder, 6,000 plus, are social sector buildings. Down the bottom, I put a reference to some recent building safety bill fact sheets which have been issued by the government in the last couple of weeks. So in this diagram, I'm trying to show what's going on in the operational management task. So just zoom in again. In the middle here, we've got a little model of what's going on. So each of these blocks is a building with red, yellow and green there, making up 3 buildings in an estate and 2 estates, making up an area. And we're managing this as an area management. And over here is all the actions that need to be done by the building management. So they might come from a fire risk assessment, a structural survey and so on. Might come from residence requests, or they might come from, I've still got MHCLG there, I'm sorry about that, that should be DLUCH now. On the far side, we have the resources which the management have available to get problems done. So red means obviously it's urgent, yellow is not so urgent, and green can wait a bit. And we hope that they all get through to being green at some point, and then we have a continuous improvement route there, hopefully, where we can measure how well it's doing. So around the outside, I've put the various management tasks. So the bottom left is the management resident's voice, and think requests and complaint procedure for dealing with residents' problems. In this box is the external consultants and contractors who might do inspections and tests and assessment of the structure and fire safety. Over here is how to manage the internal and external resources and incoming materials. And here is managing continuous improvement. And down the bottom, we put the safety case, which is an account of the current safety status of the building. So with private owned buildings, it's a little bit more complicated, whereas with a local authority or a housing association building, we pretty much have one team with the accountable person probably in the same organisation. With privately owned buildings, in most cases, the accountable person and the ownership is in one organisation, and they employ a property management company to run the building. And the building safety manager in that case is probably employed by the property management company, and the accountable person is by the ownership company. So we have a rather more complicated organisation structure, and quite who will do the safety case, we don't know, because the accountable person has to submit it, but almost certainly the building safety manager is the person who knows what to put in the safety case. There may well be a safety case advisor on the scene who helps the accountable person check that he's got a safety case he can be happy with. But in this presentation, rather than talk about different organisations, I've just called it all housing management team for both types of organisation. So we have 2 things here. We have the safety case and the safety case report. So the safety case is the whole safety information organisation supporting evidence, all the things to do with the safety of the building. The safety case report is the document that actually goes to the regulator to make the claim that the building is safe. And typically it's a claim, an argument with evidence, and stating why the accountable person thinks this building is safe. On the bottom here is just a reference to the HSE's new advice note, which came out in September, and I believe this will be followed by more from HSE as well. So we've suggesting that this work should be a 6-stage workshop series. So the housing management team gets together its people, and probably with facilitators in some cases, and goes through a series of 5 workshops following a 6th workshop where the safety case report can be put together. So workshop 1 is gathering existing information, and that's related to the golden thread thinking. In workshop 2, hazard identification. Workshop 3, using Bowtie charts and root cause analysis. In workshop 4, risk assessment. Workshop 5, the safety management system. And as said in workshop 6, the safety case report as such. So I'm going to go through each of those and try and explain what they're about. So first of all, just about the golden thread. So Lady Hackitt introduced this in her report as a golden thread of good quality information will help future building owners to better manage their buildings. If any of you are responsible for older buildings, you will know that there's probably very little information in some cases about the building, how it was built, or what kind of maintenance has been carried out. And the idea is that at least with new buildings, there should be a proper record kept. And the government would like to see this kept in digital form in a format which is open and non-proprietary with proportionate security controls. We haven't seen all of this yet, but there is a Building Regulations Advisory Committee with a Golden Thread Working Group, and that has put out some stuff, including this definition. So what information? So I think you can really put it down into two lots of kinds of information. One is about the structure of the building, how it was built, its internal structure, for example, compartmentation, if it has cladding, fascias and curtain walls and so on. And then fire and emergency data, which should be links to fire statement forms, fire strategy report, latest fire assessment, anything from a CDM work and so on. And all these need to be gathered up and, if possible, put into digital form. That's always a good thing to do now. I put this picture on the left here. This is a picture of North London. I put it up not just to make Arsenal supporters feel happy, but to point out that in most cases, these tall buildings are in groups. So, for example, near the stadium there, you can see a group of 3 high-rise buildings. And when you're gathering this information together, usually these groups of buildings have originally been built to the same design, or near enough to the same design, with perhaps 1 or 2 variations in the ground floor for a reception or something. So it makes sense to keep their information together and treat them as a group. It may be that in due course, the regulator will see the advantage of considering a little group like that for a single safety case, but at the moment they're saying 1 safety case per building. But it would seem to me that there's a big advantage in terms of the workload, both for them and for the owner of the building, to treat these as estates, because lots of things go together there. Access for safety vehicles, for example. There may be lower level buildings at the ground level which tie these buildings together, which need to be considered, and so on. So at the moment we have to have a safety case for each building, but information wise it makes sense to keep it together in terms of small estates. And you need also to have drawings. This is a typical part of a fire plan. This is a site drawing. It shows where the fire engine might come in. This is a drawing showing an estate plan. For example, here we have three identical buildings in one area. Then we have another one in another area, but we also have some low-level buildings which are kind of associated, and a plant building, I think. And then we need some cross-sections of the building. Probably, as I said, the ground floor might be different. There might be different cross-sections on different levels. So we need to get all this stuff, and the drawings may or may not be digital at the moment. You may only just have a printout of a sketch from somewhere. So what we're trying to do is answer questions. We're trying to preempt the regulator asking us, okay, you say this building is safe. Why do you think it's safe? And that means you need to answer the questions to some of the information that's in these documents. I found these particular documents useful, but there are many other documents. So obviously, approved document B is a must-have. with various B1, B2, B3, B4 up, and so on. This is the English Fire Safety in Purpose-Built Blocks of Flats, which is now, I think, published by the Home Office. And the Scottish equivalent is very useful, Practical Fire Safety Guide for Existing High-Rise Buildings. If you have one of these large panel system buildings, which there are still several hundred, I believe, then you probably need to have the BRE report. I've put a reference to these things at the end of this webinar so you can see the references. So here's an example of what should be going on in the information gathering workshop, is asking questions. So for example, ADB B1 means a warning and escape. It says the building should be designed and constructed so there are appropriate provisions for the early warning of fire, an appropriate means of escape in case of fire from the building to a place of safety outside the building, capable of being safely and effectively used at all material times. So does the building in question meet these requirements? If the answer is yes, and you are audited, can you provide the information to support this claim? So that's why we need to have this information gathered together. So the next stage is hazard identification. So there's a few definitions here. I don't go through them all, but hazard is basically something with the potential to cause harm. So in a building, generally speaking, this is fire, but it could be to do with the structure or something else. And events is when this gets out of control. Threat is something that might cause the fire to get out of control. Risk is the likelihood of an event occurring. Consequences are the unfortunate results of an event happening. So if somebody gets injured in a fire, for example, and a barrier is a type of control which might be used to try to prevent a hazard getting out of control or to mitigate the consequences of an event if it does get out of control. So here's just for a block of flats, a hazard could be a fire in an individual flat. So this is different from other industries. So we're rather unique in that in most cases, the owner of the buildings or the party responsible for the buildings, like a local authority, does not have immediate access to all the flats. They may be private, or even if they're tenants, they cannot just walk into a flat and check, for example, the safety of domestic appliances. So we have to start with a fire in an individual flat, which is a different sort of situation. An event would be, for example, fire spread, where the fire spreads from that first flat into common areas and other flats. A threat might be, for example, if the compartmentation of the flat is breached. And compartmentation in this case is a barrier to stop the fire spreading. So just to discuss this point, the HSE Safety Case Principles Guidance, and in fact the Building Safety Bill, classifies the safety risk involved in fire spread and structural failure. However, it does say that other hazards may be included in the new regime in the future when evidence supports this. And also you have to continue to comply with all the other legislation. So that would be Legionella, asbestos, gas safety, general fire precautions, pest control and so on. And also don't forget that the Health and Safety at Work Act places an obligation on the legal duty holder to identify all reasonably foreseeable hazards. And that applies not just to employees, but also to the public. So you have to think about, in your safety case preparation, about all these things. You can't just look at fire and structural failure, but those are the ones which are highlighted as being thought to be the major risks. The government actually, in their own fact sheet, says rather more. They say government commissioned research which concluded the major accident hazards would be onset of escalating fire, structural and explosion events. So they also included, I take that to be gas explosions. And though explosion events contribute rapid onset escalating fire, but I think a gas explosion is really different from fire spread. So I'd like to consider that separately. Other risks can result in a major incident when they trigger a spreading fire or a structural collapse. So, for example, flooding can cause structural damage. In analysing hazards, I want to mention Hazop, which is widely used in the petrochem industry, for example, and it's a structured way of looking at a system and analyse it to see where hazards might be. The op part of Hazop is about operability, which means the ability to keep a system safe and reliably functioning. It may be that Hazop is appropriate for some very modern complex buildings. I'm thinking particularly for some business buildings which were designed as offices originally and now are being converted for residential purposes. They may have some quite sophisticated systems involved which might need something like Hazop to analyse the hazards. So here are the hazards which I suggest you ought to consider. And I've labelled these as significant 4. And this is really a copycat from the Civil Aviation Authority, who identified a significant 7. And in their case, they said, for example, if there's something blocking a runway on an airport, that's one type of hazard. If somebody's laptop catches fire in an aeroplane, that's another kind of hazard. These are independent hazards and should be considered as such. And I've said that in a fire in a high risk building, we can take fire spread as one type, structural faults as another type. I think gas explosion should be a separate one. And I've also taken deliberate accidental fires as a 4th one and called those 4 independent hazards. I also think that although smoke obviously comes from fire, it's really the most common cause of fatalities and harm to residents. So in some ways it's useful to think of smoke as a separate hazard from the point of view as assessing risk. And then we need to be aware of what I call external hazards. So that would be flooding. It might be release of a noxious gas cloud from a factory in the same district or something like that. So the housing management team need to know about these different possibilities. So here's some pictures. This is on the left is Ronan Point. So this is a large panel system building, and you can see that the whole corner of the building has collapsed due to a gas explosion in one flat. As I say, there are still quite a few of these buildings around. None of them should have gas in any longer, but please check they haven't if you're involved in one. Over here, that one is still complete. And then over here we have Lacanau House, and you can see that fire spread has spread from, probably that was the original flat, I'm not too sure, upwards, mainly upwards, but also it seems downwards. So this was, there was loss of life at Lacanau House, very serious fire. This is a case of flooding, and you can see it's removed really all the subsoil and support from this building and exposed the piles which it's sitting on. So this has really done some potential structural damage to the building, and this had to be evacuated. And then on the right-hand side, I've put some extracts about deliberate fire rating. This has become really a major problem for many fire brigades. They're having to be called out very, very frequently for these types of things. So the bottom one there in Preston, hundreds of residents had to be evacuated from an 18-storey block of flats. So this is from the official Home Office report. In the top one is actually the Scottish Fire Rescue Service, sorry, and they say deliberate ignition was the cause of 21% of fires in high-rise buildings of 10 or more floors attended by a Scottish Fire Rescue Service. That was in 2017 and 18. And then 43 is from the Home Office report, which said in 2008, deliberate ignition was the cause of some 17% of fire in dwellings. And these fires resulted in 59 deaths and nearly 1,600 near-fatal casualties. So this is people setting fire to rubbish which has been left on the stairs, for example, or putting flammable liquids through letterboxes. One of the problems this can cause is it's a fire in the common areas, so that means evacuation is very difficult. So now we talk about Bowtie and root cause analysis. So what we're trying to do here is to show how your building is put together and how the various barriers that are being used can be identified and understood in case they begin to degrade. So it effectively gives you a model of your building. And then root cause analysis is to look at that model and say, where's it got weak points? What do we need to do to improve it? So, for example, here is a tiger in a cage. The tiger is a hazard. When the tiger's in the cage, it's no problem. As the tiger escapes, there's all kinds of problems. So we can draw a bow tie to show this zoo arrangement for the tiger. So on the left-hand side, we've got the things that might happen for the whole situation to get out of hand. So the keeper might leave the gate open, or the gate might not be strong enough to stop the tiger. In the middle, we've got the hazard, which is the tiger, and the event, which is the tiger escaping. And on the right hand, we have at the far side the consequences. So the tiger mauls or kills a member of the public. And down below that, we have the loss of the tiger, which is also a problem for the zoo. And then in between, we have various controls to try and prevent these threats and consequences happening. So on the left-hand side, the keeper leaves the gate open, and we have some sort of device for a self-closing gate, and we have an electric gate alarm to make people aware there's a problem. And on the right-hand side, to avoid members of the public getting injured or killed, we might have a search plan which is brought into action very quickly. We might have dart guns to anesthetize the tiger and stop it harming anybody. What we should notice about this is the bow tie diagram doesn't tell you the likelihood of any of these things happening. It's just a picture of the system. So here it is again with just words in the different boxes. So the hazard is the dangerous thing. The threat is something that might let the dangerous thing get out of control. The event is the dangerous thing being out of control. Mitigation is the attempt to stop that hurting anybody or doing any damage. The consequence is what finally happens. And you can see now 2 yellow boxes there. So we have control maintenance, we have to keep that working, and we have mitigation maintenance. And up at the top, we're thinking about risk assessment as we go. So if we put that now into the form for a building, we can say that fire is the hazard, fire spread is the threat we're trying to prevent, compartmentation is the prevention barrier, the building fire is where the fire is spread to the whole building, a fire alarm is our mitigation barrier, and injuries are the consequence. So now we have a fire risk assessment, for example, is one of the ways of maintaining our compartmentation, and maintenance is a way of maintaining the fire alarm. And those 2 activities will form part of our safety management system. And note that in a fire risk assessment box, I've put a plus because a fire risk assessment might happen periodically, but if anybody does any work on an individual flat and drills a hole through the compartmentation, we need to inspect that job and make sure that proper fire stopping or whatever has been done. So fire risk assessment on its own will not be enough. You need something more in your safety management system to make sure that compartmentation is properly and regularly inspected. So I also want to draw your attention to the potential of system failures. So when we have a product like a smoke detector, these are very well tested before they're released to the public. As an individual item, these are highly reliable, provided you look after the batteries and so on. But at the same time, the most common cause of death is overcome by gas and smoke. So in 30% or so of fires, and when you go into the reasons for this, we find that actually the smoke detectors didn't work in many cases, nobody heard them in other cases, and they weren't in the right place in other cases. So although you have a very reliable device, it's actually the system isn't really performing. So the system reliability can be very different from the product reliability. And this is something we have to keep in mind, particularly when we come later on to root cause analysis. So you might want to make sure that you also have in your building smoke ventilation. There's a little diagram on the right, thanks to Colt. And many buildings have one form or another of a smoke ventilation shaft. Of course, we need to have this in good order so that the smoke doesn't go from flat on the 3rd floor and then go in through the vent on the 4th floor. So this needs to be maintained in good order. If there's a mechanical or automatic system in place, we need maintenance. So this again is a mitigation barrier. So now we've got these two different layers of mitigation barrier, smoke detector and the smoke ventilation. So many of you will have seen this Swiss cheese model, and this is something like the same. So here, James Reason's model tries to show that each of the barriers will have some holes in it, like a Swiss cheese. So something is likely to get through each of your barriers. It's very unlikely to be 100% okay. There's always going to be a bit of loss through it. So the more barriers you have, the less likely this is going to happen. Another little problem we have is with sprinklers. So prior to 2007, buildings did not have to have sprinklers even if they're over 30 meters. And then from 2007, buildings over 30 meters have to have a sprinkler fitted. And from May 2020, I think the height requirement was lowered to, I believe, 11 meters. So more modern buildings do have sprinklers in general, but the older ones don't. And we know that sprinklers do add to safety. So I'll just come back to that one. Sorry, Mr. Elton. Okay, so Bowtie limitations. So one thing we have to be careful of is common cause failure. So you might have a smoke detector and a fire alarm operating off the same common power supply. So if the common power supply fails, then both those barriers will be disabled. Another problem which comes up is overrides, so that during maintenance, for example, the fire alarms could be switched off, and has anybody switched them on again? And then we have what's called creeping degradation. So for example, compartmentation, if it wasn't built very well in the first case, might slowly become degraded and deteriorate and no longer really do its full job. So we now have a full kind of system here with more things in. I've put in fire spread and then a sprinkler system, compartmentation, two smoke detector and smoke ventilation, fire alarm system and evacuation. So then you're beginning to build up a picture of your building. So the idea of this workshop is that everybody as a team builds up a picture of their particular building, and each building will be different, and you need to put this all together. There are various software systems which will do this for you. You can feed them into software, but I strongly recommend that in the first case, unless you already have a system drawing like this, you do it as a, sticky notes on a wall or something like that, because you find that you need to move things around quite a lot at first and get the system right. Now, the sprinkler system raises the question that if your building doesn't have the sprinkler, is it as safe as it could be? The answer obviously is not quite, or not a lot. So this is something we have to come back to at the end. I just wanted to go back to a slide which got slightly out of order, I'm afraid. So this is a slide using software called Bowtie XP. And you can see here it's very complicated. And this is because each of the barriers are these rectangles of different colors here. The color just says how effective they are. So yellow means partially effective, green means very effective, red means not very effective or ineffective. And with each barrier, you can attach all kinds of things. For example, the responsible party who's responsible for it. You could attach critical document. You could put all kinds of different information in there which you want to keep an eye on. So it all becomes quite complicated. But I think at the first stage, I would suggest that you put together quite a simple bow tie, and then perhaps later on you can build up these different things. And Bowtie XP allows you, for example, to export a list of who is responsible for which part of the system. So having got your model of your system, then you can start to look and see where it's weak. In the chemical industry, of course, people have piping and instrument system reports, so that's quite easy. But in buildings, we don't really have that in many cases. So using a bow tie model is perhaps best we have at the moment. And I'm suggesting you could use something like the 5 why method to identify possible root causes. So what you can do is take a major accident scenario. So you can say, okay, we had fire spread in our building. It spread to, let's say, 3 floors. You can imagine the particular scenario and then say, okay, what went wrong? Why didn't our system stop this fire and prevent people getting hurt and so on? And the 5 why system just consists of asking the question why 5 times. So you might say, fire alarm system didn't work. Why? Because nobody heard it. Why? The power was off. Why? And so on. And go through 5 whys is the idea, and that usually identifies a root cause. And then you can ask 3 questions, which is prevent. Which barriers did not prevent the accident from occurring, and why did your SMS system not prevent the failure? Protect. Which barriers did not protect occupants from the effects of this major accident scenario? And why do your quality processes not protect the residents? And predict. Why do your SMS and quality systems not predict this was a probable safety system failure? So you're asking questions again so that at the end of the day, you can say, we know the risk of this system failing is very low. We're happy to go forward to the regulator and say this is a safe building as far as it possibly can be. So now we come to risk assessment. It's not an exact science. There's always a certain degree of subjectivity. But the housing management team is going to have to make an assessment of the risk of a major safety event in the building under consideration. Nobody else is going to do that for them. They have to do that. And the accountable person is having to go forward to the regulator to say all reasonable steps have been taken to reduce this risk as much as possible. So assessing the risk, having examined the building safety system for fire and smoke protection using Bowtie root cause, checked the building structural assessments, cladding, fascias and so on, made sure all regulatory requirements like Legionella, other inspections and maintenance are in order, checked external risks such as flooding. Are you satisfied that all reasonable foreseeable risks have been considered? The building management team is then in a position to assess the overall risk and decide whether the risk is as low as reasonably practical or that all reasonable steps have been taken to reduce the risk. So how do you present this risk? Well, probably most people are familiar with risk registers. So that's basically a list of potential hazards and outcomes arranged in order of risk, and it might just be in red, yellow and green risk levels, and that's very common and works okay. So in this case, this is Haringey Borough Resilience Forum looking at flooding. They have the River Lee running through their area with a total of 6,000 plus properties within flood zone 2. So they score that as a high risk. More commonly with risk assessments now, we see this type of matrix is actually a three-dimensional matrix presented in 2 dimensions. So we have four matrices, one for consequences which might affect people, one for the consequences that might affect assets, one for the consequences that might affect the environment, and one for the consequences that might affect the reputation. So going back to our tiger in the zoo, if tiger escapes, the reputation of the zoo is likely to be quite severely harmed. In each case, we now have 5 levels of possibility. So for people, we have slight injury or no injury, minor, major, fatality, and multiple fatalities. For assets, we might have slight damage or no damage, minor, local, major, and extensive, and so on. Then over here, we have the likelihood of this happening, very unlikely, unlikely, possible, likely, and very likely. So, for example, we might say that minor injury to people is possible, but we might say major damage to the asset is highly likely due to a particular event. And also, we still have red, yellow, and green here. So some people like to use this type of matrix to say what's going on. The safety management system. So in the Hackitt report, safety management systems are mentioned numerous times and are really shown to be a necessary part of the safety control procedure. In the Building Safety Bill, for a reason I don't know, safety management systems as such are not mentioned. They just say it may and give effect to arrangements for the purpose of ensuring the effective planning, organisation, control, monitoring, and review of steps taken under this section, which sounds to me very much like the definition of a safety management system. But then in the Health and Safety Executive Safety Case Principles guideline, it again refers to safety management systems. So I think you can be quite clear this is an essential part of the overall regime. So the safety management system is a systematic approach to managing safety, including organisational structures, accountability policies and procedures. And the day-to-day work of maintaining safety in the HRRB is carried out under the safety management system. So it's nice that this SMS is structured according to the ISO structure, the high-level structure which you see on the right here, because that means it's compatible with other management systems which may already be in place, such as 55,000 is the asset management system, 45,001 is the health and safety system, or ISO 9001 quality system. And then you can run these as multiple ISO systems in line with each other. Some people are just using maintenance systems, and that needs a bit of upgrading. So in a typical estate or area, you will only have one safety management system, but you will have safety cases for each building. And here's some documents which you can look at to get an idea about safety management systems. The left-hand one is the civil aviation people's safety management systems for smaller organisations. They also do a much more detailed document for larger organisations. And on the right is an HSE document for managing health and safety, which is about safety management systems for exactly that, for health and safety. So they may be helpful. So just to come back to this picture again, the safety management system is what keeps all these operational management tasks working correctly and seeking continuous improvement. So for continuous improvement, you will need to measure some metrics. So it might be, for example, how long does it take a red action point here to get through to being a green fixed problem. So now finally to the safety case report. So basically what you're doing is putting an argument supported by evidence that this building is safe because. So I like this quotation from Nancy Leveson, Professor Nancy Leveson of MIT. I think this is a very important quotation. It says, it can be argued that no system is completely safe, which I think we all would agree with. So the goal of the argument is actually untrue before starting. If instead the goal is to show the system is acceptably safe, then the problem simply devolves to defining what is acceptable and to whom, perhaps to the producer of the system who's paying the cost of making it safe, or to the potential victim. The concept of a LARP is the British attempt to answer that question. So a LARP is one of two ways of expressing this. LARP is as low as is reasonably practical, and S-therapy is the risk has been minimised so far as is reasonably practical. So they're almost the same thing, but not quite. Clause 73 in the Building Safety Bill uses the term all reasonable steps, which is meant to imply a LARP or S-therapy. So I thought it's worth mentioning COMAR. COMAR is a control of major accidents and hazards regulations. And it doesn't apply to high-rise buildings. It applies to sites which have quite large quantities of stored chemicals and other hazardous substances. But it's very interesting and useful to read the regulations because they illustrate how the Health and Safety Executive runs one of these types of regulation processes. So, for example, here is a summary written in IChemE technical paper, and it says that COMAR demands that you demonstrate that you have assessed the risks of fatalities and major accidents to the environment and performed Hazops and developed Bowties to identify the major accident hazards and perform consequent modelling and so on. And down the bottom it says correct execution of critical activities, including competence assurance of relevant personnel. And I think this is the first time I've mentioned this, but I think you will find that the regulator is really very interested in competence assurance of relevant personnel. So I would ask you to take note of this and perhaps have a read up of COMAR information. A particularly easy one to find is this HSE information sheet called Chemical Sheet number 3, or CHIS 3, I think it's referred to, which is major accident prevention policies for the lower tier COMAR establishments. That's people with comparatively low quantities of hazardous chemicals. And down the bottom it says that the information should be expressed in a MAP document, which is something like our safety case report. And that should include your policy, your statement of intent, setting out your aims, principles of action with respect to the prevention of major accidents, and a description of your safety management system for achieving the stated aims. And if you look at the COMAR information on the HSE site, you will see a lot of information about inspection. And nobody's mentioned inspection so far in any of the regulations, but I think we will see in due course inspectors coming out to high-rise buildings from time to time, perhaps just to do sample inspection. So two other things. The safety case report should be a well-reasoned argument, a qualitative rational explanation of how all reasonably foreseeable hazards have been systematically identified, and then a reference back to the old Nimrod review, which was the accident report on the Nimrod crash done by Charles Haddon Cave QC. And he was really very disturbed by having enormous documents which didn't really mean anything. So he said that in future, safety cases, which he preferred to call risk cases, should follow the 6 following principles. They should be succinct, homegrown, that means written by yourselves, accessible, proportionate, easy to understand, and document light. And I think the regulator will certainly agree with that. He has a lot to go through. One question which we've asked is, will the British standards or other guidance be developed for a suitable safety management system? At the moment, there's no plan to do that. There is BS 9997, which is a fire risk management system, which will form a good basis for a general safety management system. And many people, as I mentioned before, have already got other management systems, ISO systems and so on in place. But at the moment, there's no intention to develop a specific standard. I believe there should be. I believe it's something that should be done. And finally here we've got a template which we suggest for safety case report. So this is something to, if you like, take away and look at. Everybody will have to come to the conclusion of what they want in their own report, but these are some suggested headings that you could put in. I think it will help people. And final thought from James Ing: a main disadvantage of the safety case approach is that it can be very difficult to determine precisely what level of evidence is sufficient for a given system. How do you really show that something is safe? This becomes an engineering judgment based on the experience of those managing safety and their advisors. The safety case approach requires a greater degree of competence from those involved in it than does a prescriptive approach to safety, where managers can achieve compliance by following rules rather than making decisions. In other words, to get this done right, we need some good professional engineering. I've put on the back of this talk, I think altogether 4 pages of further reading. I haven't called it a biography or anything. I would suggest that if anybody hasn't seen it, Dr. Barbara Lane's presentation of evidence, expert evidence to the Grenfell Tower Inquiry, Part 1, is something that everybody should read if they're involved in this kind of work. There's a whole list of other ones there. And at the end, if you are really interested in ALARP and what it's all about, there's a new document there from IMACE, which is how ALARP works and what the legal business is surrounding it. So thank you very much for your time. I hope you found something useful here. I believe this talk will be available at a later date on YouTube, where you can watch it again or introduce it to other people. Thank you.
Thank you, Brian.
Thank you very much.
No problem. Okay, so a lot of people were sending in messages and questions during that.
Okay.
I'm just trying to find them.
Just shutting down my PowerPoint. There we go. What's doing this? Okay. Yep.
Right, let me see.
We managed to consolidate them a little bit.
There is a lot, so I will probably
we'll do what we can. Yeah. Okay.
But it looks like there are a few where fellow attendees have answered them for you.
Okay. So what was it? It's useful to know what the question was about. In the general sense.
Right. Okay. Let me have a look. Right. So we've got. So obviously, excuse my pronunciation because I don't necessarily understand the terms myself. Yeah, so we've got one asking if FAR is considered in the new regime. I'm hoping that you understand what that means.
I think that stands for Fire Accident Report, probably. I don't think that's mentioned in the Building Safety Bill as such. I stand to be corrected here. I think that's under other legislation. I think they probably mean FRA, which is Fire Risk Assessment, in which case, yeah, definitely that's a key action which has to be taken by everybody.
Right, okay. So the same person has just put in what they meant, and they meant floor area ratio.
Oh, floor area ratio. Okay, so I think this is to do with what you might call fire strategy. So when a building is designed, they try to design the building from a fire risk point of view so that the proportions of rooms and so on work out right, and also so things like the distance people have to go to escape is under control. What we're talking about in this safety case review is about post-occupancy. So we're not talking about the design of a new building, we're talking about having to deal with a building which already exists. In many cases, it's older buildings which haven't been modified or anything, so we've really just got to take what we've got in that case. So it's possible that with a new building, a building safety manager or an accountable person might get appointed before the building is finished and handed over, but they are unlikely to be appointed before the building is designed. So I think, again, even with a new building, people are probably going to have to take what they get. Steve Wiper has come up saying, will the slide set be available? The answer is yes, it's going on YouTube, isn't it, Jordan? So in a few days' time, it will be on YouTube.
Yes, it will be. As soon as I can get the video downloaded and then put back up on YouTube, it will be
I think
there.
you go to CABE YouTube and then you get it on Google, I think.
Yeah, it will be uploaded to the CABE YouTube channel. Okay, the other questions that have been sent in are quite lengthy, so I think the best thing to probably do is to not put you on the spot with them, but to send you them through an email, and then I can send the response to the relevant person.
Are you able to bring the chat's here? Can I bring the chat up?
Yeah, you should be able to see it yourself.
Yeah, okay, I've got the chat up now.
There's the chat and the Q&A, so they're in both of them.
Okay, it says, please show the second template page. I thought I did that, but I can put it up again. The second template page, okay. Just a minute, I have to go and get it. Share the screen. No, sorry, gone too far. Okay, that's template page 1. I noticed there's 2 number 6s there. Sorry about that. Somebody's gone wrong. My counting. So one of those number 6s should be number 7, obviously. This is the second page. I think that's what people wanted. Okay. So this will be available when it comes out on YouTube. You'll be able to see this. If anybody specifically wants one of these slides, for example, if you send your email through to Jordan, she can send it on, and I'll quite happy to send that out. Specific slides like that. Okay, what else we got here? go to the beginning. How can data related to sensitive building facilities be made public, such as? I think with private buildings, this is very difficult. I think with actual public buildings, like local authority-owned high-rises, for example, generally speaking, their information is public. So you find that if you go to, like I showed you, risk register from Haringey, this is all online. You can get all this stuff publicly. Even fire risk assessments of buildings usually are online. If you go to the appropriate council's website, they usually have all this stuff. But if it's something like a bank, well, we're not talking about banks. We're talking about high-rise residential buildings. How granular does the golden thread of information need to be? Oh, I understand that, yes. So I think a building owner only needs to know that the door is correct. He's talking about fire doors here. So the building owner needs to know that he's bought a door which is correctly fireproof with a sufficient number of minutes of fireproofness or whatever, and that he can trace back the door to say who made this door and do they have the necessary credentials to show that their doors have been made to quality specification. So it's not so much about having the granularity of how the door is made, it's about the granularity of knowing the source of the door, where it came from, who made it, do they have proper quality control procedures in place, was it made to the correct British standard, and so on. So you need traceability is what we're talking about, really. This is, oh, okay. Okay, I haven't got really, there's not much more there, Jordan. I think we've got most of them. So if anybody wants to write in, that's fine. Go right into you, Jordan.
Yeah, of course. If anyone's got any feedback, comments in general, any further questions, just send them through to myself and then I can let Brian know.
Okay.
So just before we finish, obviously just want to thank Brian for joining us today and everyone who has logged on as well. I think it's been really productive and you've got a lot of questions, which is very positive. Before we finish, the webinar program for the rest of 2021, I nearly said 2020 then, is now all arranged. So do take a look on our website. We've got some interesting topics to finish off the year with. And I am beginning to organise the first half of next year as well. So keep your eyes peeled. As mentioned, this will go up on YouTube as soon as I can get it up there. But if anyone has any questions or anything in the meantime, please do get in touch.
Okay, well, everybody's very welcome. I did make a couple of tweaks, Jordan, so I'll send you the latest copy.
Okay. Not a problem.
Okay, you're welcome. Okay, thanks a lot.
Bye.
Okay, bye everybody.